Recording. College algebra. Oh, it's not. This is environmental science. Monday, October 19th. So we're going to start with Hannah. She needs to tell us about the atomic bombs. Let's see how it's going to go. Here it is. Put this here, and we can ask her questions. And okay. Get my.
Atomic bombs. Great. Okay, so this is very interesting. Oh, okay, perfect. And you just switch it here. Okay, so I did my presentation on atomic bombs. So I started off with what is an atomic bomb. So they also call it an atom bomb. And it has violent explosive power, and it's due to the sudden release of energy resulting from the splitting of a nuclei or of a heavy chemical element. So there's the two main ones are plutonium and uranium, and it's a very rapid chain reaction, and that chain reaction is what causes the explosion. What is it made of? So the main reactive components are usually plutonium and uranium, kind of like we explained. The explosiveness of the bomb depends on fission. So again, that's the nuclear reaction. And that's where it's good. So who invented the atomic bomb? So it is Robert Oppenheimer. I think that's how you say his name. So he invented it, and then this kind of kicked off the Manhattan Project. So it was during World War II. The American physicists and engineers conducted a test, and the purpose was to win a race between Nazi Germany to become the first country to have these new weapons. So it was a pretty big deal that whoever has it first pretty much was going to win the World War II. And this project costed roughly $2 billion, which is a lot of money. So for the Manhattan Project and for the bombs dropped on Japan, the plutonium was actually made at the Hanford site that went into the bombs, which is kind of a unique fact. And the Hanford site was actually established in 1943, and it was home to the B reactor, and it was the first full-scale plutonium production reactor in the world. So it's kind of a cool thing to have that in Tri-Cities. So one of the first atomic bombs that was dropped was Hiroshima. So it was on August 6th, 1945, during World War II. The bomb, its nickname, was the Little Boy. So it was actually significantly smaller than the second one, but it's kind of crazy. It did a lot more damage because of the geography of the city. The city killed, or the explosion killed 80,000 people, and this doesn't, this is kind of morbid, but it doesn't include the people who just disappeared because of the explosion. And then also it doesn't include the people who died of radiation exposure after the fact. So it was not a good thing. Then at 11:02 a.m. They called it, where was it? Fat Man was the second bomb, so it was quite a bit bigger. And these were kind of a shock to see what it would actually do to the population for the United States. And because of the hills surrounding the city, there was a lot less death, but there was still a significant number. So, and this explosion was equivalent to 22,000 tons of TNT. So that's quite impressive. Okay, so then I kind of was interested after this. So we saw how destructive they could be to cities. And so I was wondering, how many of these do we have? How many do other countries have? And it was kind of shocking just to see how many there were all over the world. So US had the second most to Russia. And then, like, I was kind of surprised that China didn't have very many. Yeah, and there's always that possibility as well. And then, yeah, I kind of wanted to ask you guys too, like, do you think there should be atomic bombs, or what do you think about how many there are? Yeah. Just for US. Yeah, I don't think so. But yeah. Yeah, I guess it was good. There was a lot of, when I was reading, there was a lot of debate on whether the atomic bombs should be used, and kind of the argument for and against the bombs was that there would be more American lives saved. There would be less death overall if they ended the war then, instead of letting it continue on for years and years, which we probably won't ever know if that's the case or not. But yeah. Oh, so the United States thought that if they didn't end the war as soon as possible, that there would be the Second World War. Yeah. In the Second World War. So if they did it in the Second World War, then they also had like the Japanese had this like cultural like stigma that if you were fighting in war, that it was more honorable to die in war than to lose. And so what would happen is that there would be a ton of like suicide squads, is kind of what they called them. So pretty much the US was expecting all of Japan to be wiped out if they did invade, because they rather die than be invaded by the US, which is kind of crazy and very, very different culture than over here. So yeah. 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 It's really sad. Okay. Oh, Iran. Where did it? I don't know. Yeah, I don't know. I think I don't know actually, but hopefully not very many. Yeah. So, and it was interesting to me too that it was actually a German physicist who kind of came up with the concept of atomic bombs, and then America kind of jacked it and then created their own thing. I believe it was, yeah. Yeah, I would have to, it was kind of a hard name. Ernest Rutherford. Yeah. Yeah.
But I kept this chapter because I wanted to have a chapter about coronavirus. So I cut a week from this, like chapter 13, so we can have chapter 14 extra. we need to figure out what's going on. Okay, let's see. France. Why is France 300? Okay. Okay, so nuclear disasters. Ooh, let's get rid of this. Anybody? So what are the okay? So what are the if I say nuclear, like nuclear power plant disaster, what comes to your mind? What is the first? Okay, let's play this psychology game. You know, I'm saying nuclear power plant disaster. What comes to your mind? Chernobyl. What? Wait, no, this didn't come to your mind. It's not there. What did you say, Hannah?
Oh, I said Chernobyl.
Chernobyl too. Daniel, what came to your mind? Chernobyl. How about you, Elizabeth? Okay, the Chernobyl. I guess Chernobyl is the main one. Oh, and there was
one in Japan in like a movie. I think it was Godzilla.
No, but there was a real one before Godzilla.
Yeah,
There was one where Godzilla was not involved, but but I think actually I forgot. The movie Godzilla is so funny. I can start my environmental science class with clips from Godzilla, because if you watch the last Godzilla, King of Monsters, I think, the way that it's all geared towards global warming, the environment, and they're saying how, you know, the idea was at the end that the monsters, they came up because they want to restore the environment. People were so bad, you know, ruined the environment, and now the monsters came out. Because if you watch the end of the movie, they're saying, you know, after this monster, whatever, you know, the trees grew back and the ocean got cleaned and all kind of stuff. So we had to have was Godzilla was the answer to all the environmental problems. So we can summarize right this way. Okay. So there was so the different disasters. There is actually one. Which year was this? The one 3 minus. Where is it? Did it say? Hey, 1979. This is before Chernobyl, right? This is actually right, because Chernobyl was. I remember I was at the Black Sea on vacation, so I must have been more than 8 years old. Yeah. So this was before Chernobyl, and it's actually happened in America. Anybody watched the China Syndrome? He watched it. It happened after 1 week after this movie was released in the movies. This happened. So this was the biggest disaster in like America. And this is when people were wondering, should we use, is the nuclear good thing, bad thing? And this disaster happened and they didn't think it's a good thing anymore. So what's the China Syndrome? Can you explain? No, but just the term China Syndrome. Yeah. So what this happens, you know, you need water to cool down like the rods, you know, the nuclear fuel, because it's very hot in any sense. And so you need water, you know, cooling. But if something happens and the water doesn't go in, you know, cannot cool it, then this thing heats up itself and starts, you know, you have chain reaction, escapes and starts melting. And they call this China Syndrome when there is a meltdown, because they're saying, you know, from America, you know, the core starts melting, going through the earth and up to China, you know. I don't know which country they came up with it, but they just imaginary thing that there'll be the hole through the earth going to China. They call it the China Syndrome. That's what they explain. This is what the movie is called. But anyway, so 3 Mile Island, okay, so this was in America. I think nobody died. Of what? Where in the 3 miles? Yeah, this was in the movie. It was the same thing. The gauge was, you know, there was actually, it wasn't that they hadn't welded stuff well, but it's a human error. So Chernobyl, 86. Wait. Oh yeah, 86. This was 79, right? Okay, 86. So it happens. So I was, you know, I go in Bulgaria, everybody goes to the beach every summer, right? So I was there, you know, it's right across the Black Sea where it was, but they didn't tell anybody, you know, in Russia when this exploded. So nobody knew. So the Europe learned a week later when, like in Norway, I wonder if we have, oh, we don't have a map of Europe. Oh, is there a map of Europe by any chance? I think there was one right here. Oh, this Fukushima, but where is Europe? Oh, Europe is not here. Okay, hold on. So wherever, you know, Russia is right here, and Norway and Sweden are like up, like in Europe. So what happened a week later, or maybe 4 or 5 days, between 4 and 6 days, like there was a nuclear power plant in Sweden or Norway, one of those. Okay. And then, you know, the people, they have a little gate when every time you go to work, you go through to see if there is radiation. And then when you leave, also go through to see if you're radioactive by any chance, you know. So they need to clean you. And then this thing started beeping all the time. People were coming, going, they're like, what's wrong? And they figure out there's some environmental radiation from somewhere because their equipment is beeping. And they kind of traced it, you know, looked at the winds and stuff and traced it back to Chernobyl and said what's going on. And then the Russians said what's going on. So they covered it up for almost a week. So, you know, during this time where I was, I'm sure it came as, you know, plums and stuff, but yeah, okay. So here is what happened. The reactor, it was again the human error. You know, they shut it down sometimes, like in the movie. Actually, they want to shut it down and then restart it, but it didn't restart.
There's a whole like I think it's Amazon.
It's a movie.
A whole documentary on it that's like 5 or 6 episodes.
Oh, really?
It's really crazy.
There is actually, there was someone, I don't know where I saw the movie, what they did right now, they covered it, a huge international project, because it's still radioactive. And so they covered the whole thing in a metal shell. But the shell was so big that they had to slide, put mechanism to slide it. It's really cool. Okay, anyway, so here, this is the movie Grace watched. That was about, are there radioactive wolves in Chernobyl? Or no? I don't know. You tell me, what's the movie?
Well, no, I'm asking if that's what you were asking.
Yeah, I'm asking what is the deal?
Kind of. They're not like mutated or anything. They're like, they have radioactive levels, like when they'll like check them, like their fur, but they're actually pretty healthy. And it like kind of, because they're like the top predator, it shows that pretty much the whole ecosystem is pretty healthy, like all things considered. And they said like the levels aren't healthy for people to live there, but like the wild has kind of taken it back because people aren't living there anymore.
Okay. Yeah, so I mean, this was like, let's see, I have a documentary. One guy, of course, he died. Very poor guy. Let me find it, because he was a photographer, you know, and he wanted, this was totally secret, and he went there with the camera and he was filming. This black and white is silent. And of course, he died because he went almost all the way. And he filmed the whole thing. You know, this is like the city. No, they didn't tell. This is the trucks going in and out. Nobody told those people like how dangerous the soldiers, like in the bikini movie. So it is silent. There is no. So he's driving. I don't know what. So here's this is the police, how it looks. In Bulgaria, they used to look the same way. Yeah, in Bulgaria too. If they want to stop you, they have a little thingy circle that says stop, and they do like this, and you're supposed to stop. They don't go behind you with the lights, like in America. I guess. Oh, let me remove my. So he's driving there where the whole thing. This is, you know. Okay, all the soldiers are going. Let's see, how long is this? 6 minutes. Oh, let's shorten it. Keep going, keep going. So here he's going to the, because it's still, there was a fire, they need to stop it, and it's spewing a lot of radioactive material in the atmosphere. Okay, well, we need to the other Russian guys, and what they're doing. Here is the thing, I guess. Hard to see, but you see, he filmed this. He was super close. Here, all those guys are cleaning. They're building tunnels under it, okay, and so on. So, okay. There's trying to put water and sand or something on top. Okay. So anyway. Oh, the helicopter, crashed. What happened to the helicopter? I guess got entangled or something. Okay. Oh, we can stop. Yeah, so that was Chernobyl, and then it's kind of Chernobyl. Okay, and then Fukushima. This is actually what happened. It's in Japan. It happened for real. Which year was that? Hey, I didn't write which year. Well, it was about 2000, between 2008 and 2012 sometime, right? This when Fukushima happened. But there was tsunami, and I guess the wall of the reactor wasn't so as high for the tsunami, and the waves came, and they, I think the generator stopped working, and then the cooling, it couldn't cool the reactor, so it melted down. And this happened, and the plumes went all the way to United States, right here. See, in 3 days, 6 days, and 10 days, they were already here after the, yeah, after. Yeah, I'm sharing screen. Yeah, I'm sharing it. Okay. And then actually, I work at this lab here in Washington, where they brought the samples. My favorite Japanese mayonnaise. I was like, oh, they brought it, but it's just to sample with the radiation. And also here, now everybody in Washington State would send their milk, eggs, everything to test for radiation. And there was radiation in those sticks because, it came into all those products. Okay, so that was it. And we have one nuclear power plant less than 50 miles away from here. I mean, it seems super safe. No, it has too many. It has so many like foolproof 1 second, 30, like measures. So chances are super small something to happen. Okay. So now we're starting the next chapter, which is about excitement. It's about energy efficiency. How exciting can this be? Okay, so what's energy efficiency? It's 13.4. It's energy efficiency. How efficient you are. If I give you maybe the parable there when they give money to people, like, what did he give? 5 talents? What was the talents? How many talents did he give to them? 5? 1? Several people, he gave them the same amount of talents, which are money, right, in those times. And so he gave everybody, one of them buried them in the ground, the other just gained some interest, and the other invested them and gave a lot of return. This is how efficient you are with your money. How much work you can get out of each unit of energy, let's say, right? So, so what it is, so let's look. So if this is the input, energy input, let's say from fossil fuels, the red, see the red? It's moving. So if you look at the red, so this is from fossil fuels, all the energy we produce, right? Get the oil, the coal. So 83% of this energy would come from fossil fuels, the rest from nuclear and hydropower and biomass. Okay, this is the main percentage. They might have changed by now a little bit. So this goes in the economy, the U.S. economy. We are talking about United States, goes in the The economy in the industry, right, produce all kind of stuff. So what happens? You always have, when you have energy like used for work, according to the laws of thermodynamics, you always have some losses, right? Because, you know, heat escapes or things heat up themselves, the engine when you use it. So 41% escape, we cannot do anything about it. This is the nature of things. But 43% is wasted, you know, like nothing is insulated. When you, if you have a doggy door, one of those flip doggy door, you can warm your house so nice, but if your doggy door is not a very nice one, your heat will be escaping. Or in the window, you have air conditioning blasting, and then your son leaves the window open too, and you're like, well, it's such a waste, right? And you can do in industry, you can imagine those big factories, there is heat going, and you know, like lost everywhere. So you have like 40% wasted. Oopsie. And 9%, so from all this, only 9% are useful output, right? So imagine if we can save all this waste, how much less energy we need to produce. This would be amazing. This is just in industry. Okay. So here is for everyday, in everyday life. For example, remember those light bulbs, the old style? Do you have them anywhere in your house? Anybody, do you have the old light bulbs? The one with the little curly thing inside, the clear ones. You know those old-fashioned light bulbs. There is the bulb, like this is round, and there is the little, like that. This one produces light. Do you know what I'm talking about? You should. Do you have any of those in your house? No? Okay, so everybody switched to. So, because the efficiency of those was like only 5% of all the energy or the electricity goes to this bulb, goes actually to give you light. The rest, 95%, go to heat up the bulb. Okay, I use one of those because I was like, didn't want to go to the store to buy a special bulb for my fridge. So I found one little one, I put it in. Every time I open the fridge, it creates so much heat. I'm like, oh, I better close it fast. Yeah. So this one is not very efficient. Like the fluorescent ones are only 22% efficient. Now the LED, which I don't have them here, they're way more efficient, right? So there is like somebody calculated that if we switch everything to LEDs, right? But the LEDs are not those, right? They're the LEDs. If you switch everything to those, in the industry though, too. So it's a lot of switching. And they're more expensive. You can close all the 600 large coal burning plants. We can probably save all the energy coming from coal if you wanted to. But we won't because it's cheaper, right? But this is how much energy we can save. Okay. So, and one of the most inefficient engines is the internal combustion engine, what drives the car. This is super inefficient. It's only 10% of the energy produced actually goes to do useful work. Okay. Not so exciting. Okay. So one thing, you know, we can save energy is like increasing the efficiency of the engine, right? We're trying, of the vehicle. So this is until 2008. So it's not super new graph, but it's showing the fuel economy standards for vehicles, right? This is miles per gallon. So this is 25. In Europe, they're like pushing 40. Now they're pushing 50, something, right? That's why in Europe they have the little cars and they walk. Have you seen, I don't know, I think one of the James Bond movies or one of the Mission Impossible movies, they run and they get into one of those little cars. Okay. So this is one way, you know, to be more efficient, to save energy.
In Italy, all the cars are that size.
The little ones?
Like everyone drives those. There's like no trucks at all. And like their trucks are probably the size, like half the size of our vans.
Yeah. I never seen trucks in Bulgaria. I was like, you know, what is that?
Do you think it's like a cultural thing?
It is a cultural
I
thing.
definitely think it is.
But this is like, it's the price of gas, because this is the thing. It's not only cultural, but you know, like I had friends when I visit Bulgaria, and they say, "Oh, what's the price of the gas?" They call it, there is called benzene or petrol, you know. And I'm telling them, "Oh, it's like, it was $3," and they're like, "Oh, here is the same," and I'm like, "Oh, really?" But then we realize they're talking in liters. Here is per gallon. So actually, the gas is way more expensive there, right? So this is another reason. If it was so expensive, you won't be. You know, need to save. Because you. Why? I was looking. Yeah, I don't know. This morning I was drinking my coffee at the Starbucks parking lot. This is my morning, no, just Monday routine. And I'm like, this giant truck, and this guy's like, why is he has this big truck with these big wheels? Where is he going? Is he really going somewhere with this to really? What? America.
You're not wrong.
You need to have, but they're not. They're big ones like that. Yeah. Yeah. Ah,
All the farmers I know, like they have to have the trucks to pull the trailers and the horses.
yeah. Well, this makes sense, but
Like boats and stuff, because it's just
a boat. Yeah, if you have a boat, you need to pull it. I don't know. I never see farmers there. I don't, because I lived in a big city, so I never really went to see how the farms are going. But in Bulgaria, nobody owns. Before the change in the system, during the socialism, the government owns everything. So they're not farmers. You work for it's a job to farm the field. So nobody needed to have his personal truck. You know, everything was. This is what socialism is. This is what Bernie Sanders wants to do. So if you ever. Yeah. Yeah, and the government has the giant trucks, which it's not like, it's more like the mining trucks, not like, so you don't need personal truck. But it was funny, like my former husband, he, in Alaska, he had this truck, and I'm like, why do you need a truck? But he had justification. In Alaska, you need to carry your garbage to the dump yourself. So you had to have a truck to carry your garbage to the dump. You cannot put it in your van, So, but here we don't need. Okay. So what is it? Oh yeah. So if we can save a lot of money, it makes difference. If you have a giant car, you pay like probably $80 or 90 at the gas pump. I pay only 30 for the same amount of miles, because every I mean, the vehicles are made so about 300 miles is what you can go with one tank of gas. Doesn't matter. If it's a bigger vehicle, uh-huh. Uh-huh. Yeah, it is crazy. Yeah, actually, in Bulgaria, this is a joke. This was not a joke. It's a real story. They say one guy brought American car, a big one, and everybody's looking. Oh wow! And then he fused it and started going, and then all of a sudden it's not working. They're like, "What happened? Stop working!" And then after a while, they realized it ran out of gas, but they didn't expect it because they filled it, and I don't know, maybe an hour later it was out of gas, so they thought something is wrong with it. Yeah. Anyway, so now we come up, we're trying to come up with all those hybrid vehicles with electricity, kind of like plug it in. But one problem with this, everybody thinks it's so great. We're going to learn more about in the chapter about the atmosphere, but those things, you need to get the electricity from somewhere, right? So, and there is a lot of carbon dioxide production when you get the electricity. So they're not as clean as you think. And also they're expensive, so the government put subsidies in this. So it's not really, and where those money comes, the money, instead of using them, let's say, to help the poor or something, they go to put in those vehicles, which we think are like cleaner. So, okay. They're doing what they, I mean, but Tesla, what are the Tesla cars again? What kind of, the electric, but they need to charge them. Yeah.
It's kind of crazy to me, like that there's not more of them. Well, besides the price. Yeah.
Hold on,
but
let's,
they're amazing. And like in Seattle, like I had a guy who didn't fill up his car for a month because he just and he didn't even have to charge it that often.
well, let me receive government subsidies because they can be doing well with the, okay. See, they also received only 0.4 billions in federal loans and bailout support via the advance. Total subsidy value according 2.4 billions. So, because government subsidizes those things. So you're saying this is making money. I'm saying, are we paying for them to make money? To make sure. Okay. This was today subsidy value is across awards, federal grants and stuff. So it's super hard to make this car affordable, right? Be able to buy it. So if the government puts money, you a taxpayer money go, so they can make a profit. Okay. But I don't know. I was to use like, think, oh, this is the best thing ever. But then I'm like, wait, can we use those money for something else? Because all this money just like washing money away. You could take those money, put them in inventing something else instead of trying to perfect this, system, which might not be as good as we think. But here we go. There is also those hydrogen, the cars we choose with the hydrogen gas. But the problem is that, again, you need to combine the hydrogen oxygen. This is what they do. They combine the hydrogen oxygen, right? And then get the energy from there. But the problem is you need to get this hydrogen, to split, to get hydrogen and oxygen. And it takes a lot of energy and electricity to do. And as she said, Hannah said, they said it's a chicken and egg problem. You need few stations. And this is for the hydrogen cars, so not for the electric, with the same problem. But you're not going to do a lot of fuel stations before you have a lot of cars. But you cannot have a lot of cars unless you have fuel stations. So it's kind of, and again, unless the government steps in, people want to make money. Nobody would invest, no private investor would invest in that. Probably okay. So this was the vehicles. Isaac is the expert. What can you tell us about, what are your thoughts on environmental friendly vehicles?
The way I see it is, no matter what we do, it's going to happen. Hydrogen cars, electric cars, no matter what we're doing, it's always somehow going to destroy the environment.
Yeah, but
there's only so much we can do.
Yeah. But is it a bad thing to destroy the environment? Not to destroy it, but like to use it. I was reading, this is the thing, I was reading the scripture. I just remember it's in Joshua, and he was giving the land, remember, to the tribes. I wrote it down somewhere, but it's not here. So he was giving the different tribes the land. And one of the tribe said, oh, we need more land. We're too many people. He said, okay, well then you get this hill country. He said, and this is what Joshua said. He said, it's not, there are too many trees now. But what you're going to do, he said, you're going to clear the trees and make yourself a city there and think. So in the Bible, it was, God made the earth for us to inhabit, right? So it's actually totally okay to clear the trees so you can make a city. Just you need to. Yeah. And greed, because remember the fishing lab we did the first. If you think just about yourself, you take as much as you can, even if you don't need it. You want to use it without cleaning up. Think that's so?
Well, because the verse, like the wages of sin is death. It's not necessarily just like we die at the end. There's like relationships, etc. So like to me, when because we've had to start using the earth, like we're killing it too. Like but like also I don't think that means you just go out and burn everything or use as much as you can. So I feel like there has to be some type of balance, but
I mean, they should be balanced. Maybe our motives are balanced because, like in the Revelations, again, the scripture says God would punish those who destroy the earth. This is what it says exactly. So, we should not destroy it, but should use it wisely. So, if we get everybody saved and they're on the same page, then nobody. It all comes down to Jesus again. Do you know him or not? This usually solves your problems, kind of the roots. Just give me another verse, but like the root of all evil is the love of money. Yeah. Okay, so now the next one. Okay, so these were the vehicles. So this is there is idea how to do it, but what are the motives behind all this, really, to build all those cars? So who killed the electric car? Was it in this batch of movies? Which movie? Which movie did you watch, Elizabeth? The Wind. How about you, Isaac? How about you? Did you watch a movie? I think it was yesterday. Great. Was it yesterday? We'll see. Okay. Okay, we extended grace once to Isaac, so I guess we might extend grace to grace once. Okay. So you did the anyway. So okay. So another one. So buildings. So this is such a waste. Oh, okay. Buildings. So you can build buildings. Let's just start following here scenario we have. Okay, so we can build the buildings so they can be more insulated. Okay, I need to say, okay, so when I was in Japan, again, we're living, they all in the same type, unless you have some house maybe specially built, but the apartments, they have metal doors, and the metal door is like a metal door, it's thin metal door, and you have a mailbox on this door, and you can kind of see if you're at the right angle, you can see outside through the holes in the mailbox. And there is, in the winter, it's so much cold coming from this door. I'm like, why don't we do something to insulate this door? But all the stuff that they're like that. They don't have much insulation. It's so much energy, hitting this house, and then the wind, or the doggy house. We had the doggy house, and when the wind blows in West Regional, the doggy doors opens, the wind goes in and out. Okay. So we can so much insulate the buildings. Like there is, like in Sweden, in Europe, people are doing that. This is their culture. They've been insulating their buildings since they started building. They thought about things like that, I guess. So in building like houses, use 9% less energy for heating, let's say, than typical American house, 90%. So 10% of the energy you use to heat this college, you can heat the college in Sweden again, only 10%. So if your bill here is $1,000, they can do this in $100, the same thing. So there is here in the book, it was really impressive. It's called the Rocky Mountain Institute. Let's see which page is this on. It's on page 326. So they made this experiment. They built this building. So the building heating bill is less than $50 a year, for the whole year. So this house is so heavily insulated and airtight that if you have, it is actually in the mountains, the Rocky Mountains Institute, where there is snow in the winter. So just, the heat from the direct sunlight, the sun heating, the heat from the appliances and the body heat, right? It is warming up this in the winter, so there is no need of backup system, even though the winters in Colorado are very cold. So what it is, you can insulate the house so well that just your body heat, would be trapped there, so you actually won't be too cold. This is what happens when you build an igloo in the snow. If you're lost, you just build a little thing, let the snow go on, fall on you, and your body heat would be enough to support you. So it is possible, $50 for the whole year to heat a house in Colorado. I guess it's not very cold there. It's actually the same thing if it's cold, right? And if it's inside, the temperature on the outside maybe won't rise so much. They can just open the window, I guess. And this would be enough. Because the Colorado is not so hot. They're in the mountain. But so here is another example. It's a building in Chicago. One day, so this building, for one day it uses the energy enough for a city of 150,000 people. How many in Richland? I think the whole city of Richland uses less energy than this thing. It's hard to believe. Anyway, there are some companies like some in Atlanta, Georgia, some power company. They are using every energy they make, the extra energy, you know, they kind of put it back in the building and they're using it. And you can do it. So here, you have a house. You can, when you buy a house, you can actually build your house to be way more insulated. And you're going to, this is a little more expensive because you need to put the special floors, the insulation, the special windows. But you're going to use way less energy in the long run. So if I'm ever building a house, I'm doing this. So here, the windows. Are those double? I don't know. This seems a little double. But like in Bulgaria, the windows usually have two sets of windows, like one, close them and then close the other. They both open. Like there is so much distance in between both windows. And the reason is because air is very good insulator. So it doesn't let any heat going in or out when you close. So this is very important to have a double pane or triple pane windows, for example. We can put insulation, all kinds of stuff. The more air, the better. The air, vacuum is the best insulator. But if you cannot vacuum air, because there is heat, how is heat heat transferred? Heat is just the energy of particles, right? So this is inside and this is outside. So if you have your, you know, if it's outside, it's hot, right? Those are they have high kinetic energy. A bunch of like particles hit the window on the outside. If I have air here, right? Or vacuum, let's say vacuum. Vacuum is nothing, it's empty, right? So there are no particles to carry this energy. The energy is carried from a particle hitting another particle, right? And then hitting another particle. So when they come to the window, they hit the particles of the window, right? Then they want to hit other particles, but if they're not, then the heat will not get inside. The same thing with the cold. The heat always wants to go from a hot to cold. So if it's hot inside and cold outside, same thing. The heat coming here, making this warm, but there is nothing to carry it, so the heat stays inside. Again, it's physical science.
But that's not practically possible, right? Like
Well, you can have vacuum windows. You can, but it's then very. I mean, they're super thick, so it's super expensive. But at least you can use air, which has less particles than a metal door. Okay, here. We're going to make a little lab together. Okay, so another thing. Okay, you can do like it. So those patios, some people have balconies and make a little like greenhouse on their balconies. This is something to like also insulate your house. Yeah. Or another thing which is really cool. You can grow grass or trees on your roofs. Or this one. I don't like those houses because I think all the spiders and stuff, especially they had like vines on the walls in Bulgaria. But this is very, they had them, look, this is some, where was it? I don't know which city, somewhere on the ocean with this, but this really insulates the roof, let's say the house, okay. So what this is a thermogram, like this is a building in the winter, I think. They're looking where the heat is coming out from, right? Red is hot, blue is cold. So when you see red means the heat is coming. You're looking outside the house and you can see it's hot right there. So the heat is escaping. So you see how it's escaping through the windows, the doors, all those, right? Okay. Here is example of how we're going to run this. Oh no, I have it. Hold on. I'm going to get it. We're going to do a short lab quickly. The lab. Where is it? Move. Where is it? Oh, here. So here we have a house. Let's see quickly. 2 houses. Go. What you can do if you heat them up, like one of them is poorly insulated, the other is not so poorly insulated. This is inside thermometer, outside thermometer. All right. So we see how much heat escapes. Let's do high heat. Okay, power. So this is a stove. So they got heated up. So look, the temperature in one of the house is 24 degrees. The other is only 13. but outside, this one got some outside and some inside. But which one is the bad one? I think the one which kept more heat inside was the good one. Never mind. It's a bad. I didn't think through this. What it is. Okay. So what we're going to do? I need to think what it is. You're going to do a little lab. So bring your laptops. We got laptops, right? Did you read the popular thing? It says, okay, get the laptops, and it is right here. Oh, Isaac. Okay. No, I have no. Yeah, go to your car, but hurry up. Run. Okay, so what will I'll give you Grace this one. Hold on. So go to Populi lessons.
Can I do it on my phone?
No, it won't work. I think on your phone. It didn't work. No, this one won't work on the phone. So I'll give you the thing. So go on Populi. I have yours set up. Lessons and go lessons 13.4 and 13.5. Daniel, did you go on Populi? Are on Populi? Oh, go there. And there is the lessons, and this is the last lab right here. Glencoe Lab insulation properties of different materials. I knew that somebody wanted to get their laptop. I didn't expect it to be great. But...
I'm not doing great.
Yeah. Okay. Yeah. Man, this is heavy. Here's the printout of the 3 parts. This is the instructions. Everybody got instructions. So the instructions. Instructions here is the instructions video. Instructions here is the table. Like the combo table. Table. Hold on, Isaac. And then questions. Sorry. I haven't done this yet, but I just found it. It sounded like fun. Oh, it's fun. No, this puzzle. I learned this one before the time. For Populi. Second. So if you have problem with the flash thingy, I'll show you how to. Oh, how to they plug in to suit it. Okay, bye bye. Any other questions? I have these two. Oh. Did you find it, Daniel? It's your Populi and the lessons 13.4. This is work 13.4, 13.5.
What's your name? Go ahead.
The last one right here. So again, it's more fun to work together, but just follow the rules. So read the instructions. I printed the instructions right there. Yeah. I printed this. See, this is printed right there.
The insulation properties, various materials.
Yeah, let's see. I'll read too. See how it goes.
Wait, so
Yes.
we're just recording, like, we put each of these things in there on the table, and then we record what happens.
I think so. Where is it? Where is it? Oh, here.
Because it says, like,
Yeah.
brick, fiberglass, sawdust, and soil. So those are the ones you're testing?
Yeah. You see them at the bricks? Do you see the bricks?
Yeah.
Yeah.
Put that
So
there and then we go.
I don't know what the time has to do with anything.
Put it in that down.
Again, I haven't done this one, so I'm looking to see how it works. But we're very smart bunch, so we're figuring it out. So first, you need to make a you need to have a hypothesis. Where? On the questions? Yeah. No, not the computer. You enter it here on the paper. Like this is like first state what you want to find out about the insulating material. Way to find out if they work well, or which insulates more. Then make a hypothesis.
So we're stating like which one we think out of these four
Uh,
graphs.
But the thing is, which graphs?
This graph,
This is a graph. It's a table.
the table.
Okay. Okay. So hold on. But I think why there are 6 here? They're
Yeah,
not.
that's what I was wondering. So are we just doing the four that are on?
Oh, yeah. What happened to the other one? So we have brick, fiberglass, sawdust. So okay, so then add them. Okay, so add them because yeah, because what if you think those are the ones?
Oh wait, what? Do we only have to test the ones that we think work?
Uh,
Testing all of them.
yeah, 3, 2, 3. Try to find the 3 best. But no, I wanted to make it choice. You need to pick from the 6 because I think the one which are the best are not even on here. Oh, I think so. Oh, fine. Let's do that. Okay. Yeah, let's do that. Not sure, but I'll make a process. Keep the measure. Okay. Okay, this is what you do. So select 3 materials. And hopefully different people select different materials. Oh yeah, decide which 3 of the materials you will use. Okay, good. So make hypothesis before you start on the questions, which would you think are best. And then let's see what happens after that. Wait, don't need to carry them. Carry it, Isaac, carry it. She take it. Carry it like that. See? And then go. Okay, we don't need the wall. You carry it inside. You carry it like, you see, carry it. Oh, too loud. Oh God, let's. But it's fun. Okay, so carry those. Carry and then what? So the time, I think you're looking at the temperature. What is this sound? You're recording the temperature, I believe. Temperature inside, what are you recording inside? The transfer, the kinetic energy of the molecules. Because the kinetic energy is what temperature is. Wait, what do you record in the table? Just power it in there in a box. Wait, what do you record in the table? Did they say? Drag insulation. You see, number 3 says drag insulation. Kinetic K. Like kinetic exercise, like.
Indoor temperature.
Okay. Record the temperature in the appropriate column in the table. Okay. Take the material by recording the indoor temp. Oh, there. I guess by measuring the temperature in degrees every 2 hours in the appropriate place in the table. Yeah, okay, just say your.
Wait, I think insulate birds.
Yeah.
Does it insulate other things?
Well, it's your hypothesis. It's your hypothesis. Wait, where is the graph button? Do you see the graph button? It says click the graph button to see different interpretation, but I don't see it.
It's right there in the
It says table graph.
Where?
left.
That's good. That one.
Oh, but to do this, you need to put the data in here. So put your numbers in here, and then you can see a graph. So you have to actually put them on the paper, and then you can enter them. Fill them on the paper first, and then you can enter them on the computer to see a graph. But again, you have different names, so you have to know which table is first, second, and third for you. Let's see. Can I graph something? Okay, how many do I need to do? I guess you need to restart over somehow. press, if you do the go, it would restart. Oh, wow. Oh, come on. Oh my gosh. Do you do the whole thing to see the graph? Oh, we might need to. I'll see one graph. Just work in your table now in the paper, and I'll see if the graphs are anything worth doing. Yeah, you need to look at the graph probably to see, you know. Let me stop recording right now.